So welcome to third semester mechanical engineering students. Today we will discuss about the transducers. So what are transducers? It's a device which converts one type of variable into electrical quantities. The variables can be position, displacement, or thermal variable, optical signals. So all these can be converted into electrical quantities. Once they are converted into electrical quantities, they can be amplified and they can be recorded. So broadly, transducers convert one form of energy into another form of energy. It is also called as prime sensor or signal generator or pickup. In transducers, the efficiency can be measured by the ratio of output to the input. So when we are choosing the transducers, what are the characteristics we should expect from the good transducer? The transducer should be compact in size and less in weight. It should have very good reliability. It should have high sensitivity. Sensitivity means it should respond even to a very small input. That is the meaning of high sensitivity. It should be accurate to measure the fact transient pressures. It should maintain stability with environmental changes. The transducer should develop linear relationship between input and output. What is linear relationship? It means as the input changes, the output also should change proportionately. Preferably, transducers are supposed to give linear relationship between the input and output. It should be available at lowest possible costs and easy of producing and fabricating it. So certain qualities are expected of a transducer. How to select the transducers? While selecting the transducers, some important parameters are to be looked into, and they are the nature of measurement to be made, which type of measurement we are making, mechanical input characteristics like linearity, mechanical hysteresis, and viscous flow or creep. Loading effect of the transducers. Then environmental factors. Capability of the transducers. Compatibility of the transducer and measuring systems. Then economical factors also need to be considered. So these are some of the transducer selection factors. Then there are variety of transducers which we will see now. Self-generating type of transducer. Self-generating analog transducer. These are also called as voltage and current generating analog transducer. So as the name itself says, they are generating voltage and current. That is, the self-generating analog transducers, they produce electrical output signal which is proportional to the continuous measurement of input parameter variations. It needs no outside source of power. That is, there is no need to supply the power from outside, but instead they can generate sufficient voltage or current for the measurement purposes with a simple circuit. Examples are photoelectric cell. So in photoelectric cell, photo means light. Light is converted into current or voltage. That is, we are able to generate the current and voltage in this type of transducer. That is photoelectric cell. Similarly, we have got piezoelectric crystals. So in piezoelectric crystals, the certain crystals, when they are subjected to force, they are generating voltage. So that is also a self-generating transducer. Then there is similarly you have got radioactive type of transducer. So all these types of transducers are giving us current or voltage without the external source of power. Hence they are called as self-generating type of transducer. Then we have variable parameter analog transducer. What is variable parameter? So variable parameter analog transducers are almost similar to self-generating type of transducers. The only difference is they produce the output which is proportional to a fraction of the original resistance or inductance or capacitance, which in turn are translated into corresponding voltages or current effects. It requires the auxiliary circuitry requiring electric power supply with auxiliary circuitry. That means it is similar to the previous one, self-generating type, with an exception that the fraction of the resistance and inductance is used, and that is translated into corresponding voltages. Then we have pulse type or frequency generating type of transducers. So these are frequency generating or frequency modulating and pulse counter type of transducers. So what are the frequency generating transducers? In this type, pulse or frequency generating types transducers, these are those which produce the voltage pulses whose frequency or random pulse and whose frequency generation rate is proportional to the input parameter variations. Because the frequency is an analogous quantity, the transducer may be treated as either analog or digital type depending upon the output. Frequency and pulse signals, after undergoing the counting process, can be made digital in nature and they can be subsequently changed into one of the standard digital codes for computation or handling in data processing systems. Examples for these are frequency generating type of transducer, frequency modulating type of transducers, and pulse counter type of transducers. Then we have digital transducers. Digital transducers are those which produce specially coded current voltage for each discrete value that is sensed. So, as the input parameter changes, the fresh value of the coded signal are generated by the transducers. In digital transducers, there is no loss in quantity of signal during the transmission, even in the presence of noise and interference. Without use any complex equipment, the digital transducers produce an output signal in a digitally coded form. So, in digital transducers, in spite of the noise and disturbances, still we are able to get the digital quantity or digital signal which is proportional to the input. Now we will see transducer actuating mechanisms. So what is transducer? Which converts one variable into another variable, preferably electrical signal. So in transducer actuating mechanisms, which are also known as pickups, they have two basic elements. One is actuating device and the other one is a transducing element. Few of these utilize the transducing element directly, such as strain gauges, photocells or thermocouples or etc. So there is transducing element which is used directly. There is no actuating mechanisms in strain gauges, photocells and thermocouples. In these three that is listed here, they will not make use of the actuating mechanism. They directly have the transducing element, that is the conversion element. Then these actuating mechanisms, they are used in some devices like bellows, diaphragms, Borden tubes, proving rings, and cantilever beams. So these are using the actuating mechanisms. We will see now what the transducer actuating mechanisms do. These are elastic members which, when subjected to the pressure, they get deformed. So when the elastic members are subjected to pressure, they get deformed means they are showing displacement. Deformation can be measured either by mechanical means or electrical means. These mechanisms are converted to use and they can cover a wide range of pressure depending upon the design of elastic elements. We will see various actuating mechanisms in this diagram. So it shows, as we have said previously, they are basically converting pressure into displacement. The first one you can see the diaphragms. Only type is different. This is a flat diaphragm. So pressure is converted into displacement in the diaphragms. This is the diagram of the diaphragm. So it is pressure is sensed and final output is displacement. Corrugated diaphragm. Here also it is sensing the pressure. Pressure is converted into displacement. Like capsules, pressure is converted to displacement. So all these are actuating mechanisms. Similarly, we have got the bellows, which convert bellows. These are converting force into displacement. This is the force and we are getting the displacement here. We have got the same arrangement for pressure also. It is a circular Bourdon tube. This one is circular Bourdon tube. So pressure is the input here and we are having the displacement for Bourdon tube. We have got different types of Bourdon tubes. This is a twisted Bourdon tube. This is the pressure that is applied here and displacement. Okay. Then there is a straight tube, pressure converted to displacement, mass cantilever, and there are some pivot points for the torque. So all these are shown to understand the actuating mechanisms. What are these actuating mechanisms? As we have said, they directly convert pressure into displacement. These are nothing but the elastic members. These are all the elastic members converting pressure into displacement. Now, the transducer has two basic elements, as we have already said. One is an actuating device and the other one is a transducing element. Transducing element is conversion element. Actuating device is like a sensor it is. So some transducers, they utilize the directly transducing element like strain gauge, photocell, thermocouple, etc. as we have seen previously. So what are these transducing elements or rather actuating mechanisms? These are the actuating mechanisms that are listed here. Some transducers use the actuating mechanisms like these. Diaphragms, it can be flat, corrugated or capsule as we have seen here. A diaphragm can be flat, corrugated or it can be capsule type. Then bellows, which we have seen here, bellows, it is here, bellows. This is also one actuating mechanism. Then there is Bourdon tube. It can be circular or twisted. Then the actuating mechanisms are there for shaft rotations. It can be pivot torque or unrestrained type. Then for rectilinear motions, vanes, proving rings, also for converting pressure into displacement, proving rings. Seismic mass and springs. Springs convert force into displacement. This is also an actuating element. Then we have vanes and cantilever beams. So these are different actuating mechanisms. Without actuating mechanisms, it is difficult to imagine the transducers. So there are different types of self-generating transducers. We have seen previously self-generating is without the external power, they generate current or voltage. There are some examples like piezoelectric transducer. Piezoelectric transducer, it converts force or vibration into voltage. Then there is thermoelectric transducers. Temperature is converted into voltage. Example is thermocouple. Magnetoelectric transducers. Then electron tube transducers, electrokinetic transducer, radioactivity transducer. So all these things are self-generating types of transducers. So we have said piezoelectric transducer. What is piezoelectric transducer? There are some materials like quartz or Rochelle salt which exhibit the property of piezoelectric effect. What is this piezoelectric effect is? When this crystalline material, this is a crystal like material, this is subjected to force here. This force can be compressive force or tensile force. When this is subjected to force from both the ends, the voltage is generated. This is the output voltage. Even the reverse is true. When voltage is generated, the crystal starts vibrating. That is, even reverse is also true. So when a piezoelectric material is subjected to vibration or a force, the voltage is generated. And even if it is subjected to voltage, the crystal like material, it starts vibrating. So this is known as piezoelectric effect, and the corresponding material is piezoelectric transducer. So we are converting force, which is one type of variable, into electrical quantity. That is exactly the meaning of transducer. Then what is piezoelectric transducer? We have seen that already. So these piezoelectric transducers are certain substances which generate the voltage. It is written here clearly about the piezoelectric transducers. So they are certain substances which generate the voltages, which is nothing but electric charge, when they are subjected to mechanical forces or stresses along specific planes. That is, when they are deformed. In this way, mechanical force can be sensed and into electrical signal, which operates an indicating device. Such types of transducers are called piezoelectric transducers. These substances are generally crystals, and there can be two types of them. They can be natural materials like quartz. Quartz is the best example for piezoelectric material. Then there also can be synthetic materials like Rochelle salt, barium titrate, ammonium dihydrogen phosphate. Then how the voltage is given by this equation. E is equal to G into T into P. G is the voltage sensitivity, T is the crystal thickness, and P is the pressure. So the output is given by this equation. So what is the arrangement? The metallic electrodes are attached to the selected faces of a crystal in order to detect the electrical change developed. The magnitude and polarity of the induced change on the crystal surface is proportional to the magnitude and direction of the applied force, and it is given by this equation. So what are the advantages of piezoelectric transducers? It's having high response, good output, very compact in size, rigid in construction, negligible phase shift. Then there are some disadvantages. It cannot measure the static conditions. Its output is affected by the change in temperature, and they have poor steady state response. So this is regarding the transducers.